Hello, algebra students. Mr. Lawrence here, and this is your video for, I think it's Monday, the day before election day, which means we're off school tomorrow. We're going to be talking some more about zero and negative exponents like we did in class today. Now, on that worksheet we did in class, you saw a table, something like this, where we had numbers being raised to a power, the same base being raised to different powers, and the powers were going down as you went down the chart. Let's fill this out really quick and remind ourselves 5 to the third is 125, right? Because 5 times 5 times 5. Okay, and 5 to the second is 25, and 5 to the first is 5. Now, how am I moving? Well, I'm dividing by 5, right? I'm dividing by 5 as I move down. I don't know if you'll remember, but Fridays in my 7th period class, many of you took a stab at what a number to the 0 power was, and Dylan Nagy guessed 1. He wasn't sure why. Well, let's see if he's right. Divide by 5. And sure enough, 5 divided by 5 is 1. Absolutely. Now, many of you think with the next one that there has to be a negative answer. No, there is no negative fraction in this situation. A negative exponent does not mean a negative number. It does not mean multiply. Remember we talked about that? Yeah, it doesn't mean multiply. Remember Julianne said in 8th period, oh, it just makes so much sense. When we see an exponent, we're not thinking multiplication. Okay, so when we go to do the 5 to the negative first, we're not thinking 5 times negative 1. No. All right, look, when we move to 125, I mean, that's the same as 5 cubed, right? To 25, which is the same as 5 squared, we divided by 5, didn't we? And then when we went down to 5 to the first, we divided by 5, and 5 to the 0, we divide by 5. So let's just divide by 5. Take the previous number and divide by 5. 5 to the negative first is 1/5. A negative exponent, have you written this down already? A negative exponent, you got to get this down if you don't have it already. A negative exponent means to use the reciprocal. A negative exponent means to use the reciprocal. A negative exponent means to use the reciprocal. Okay, so 5 to the negative second. Well, I'm going to figure out what 5 to the second is. 5 to the second, well, that's 25. 5 to the negative second is 1 over 25. I use the reciprocal. 5 to the negative third, well, it must be 1 over 125. Now, hey, by the way, what would 2/3 to the negative second be? Well, I would take the reciprocal of 2/3, which would be 3/2, and then I would just square them both. 3 squared is 9, and 2 squared is 4. And there you go. If you wanted to go mixed number, you could go 2 1/4. See how I did that? The negative reciprocal, or the negative exponent, means to use the reciprocal. And notice the negative is gone because I'm using the reciprocal. Yeah, let's look at a couple more like that real quick. How about 3/5 to the negative first? Well, the negative exponent means to use the reciprocal, so I'm going to have 5/3, and that would be to the first power, but 5 to the first is 5. 3 to the first is 3, and ignore that little stray dot there. There we go. There you go. Pretty simple. Yeah, don't make this tough. How about 7/8 to the negative second? Well, I'm going to take care of this negative exponent, so I will use the reciprocal. And then I'll square both numbers. I'll square this 8, and I'll square the 7. If I want to go mixed number, let's see, it's going to go in 1, I think 1549s, I believe, right? By the way, I'm expecting you to know how to do this. If you don't know how to do it, get your butt in for help after school one day or at lunch or something, and I will certainly help you out. Oh, by the way, remember the Algebra Party Wednesday is changed to Thursday because Mr. Lawrence has a dentist appointment, okay? So there is no Algebra Party Wednesday, November 5th. It's Thursday, November 6th. All right, that's the video quiz. All right, now, to further explain this idea of zero exponent, we know that x to the 7th divided by x to the 4th is the same as x to the 7 minus 4, right? We subtract the exponents because it's division, and then we get x cubed. Taking that logic, wouldn't this become x to the 7 minus 7th power, which is, of course, 0, but isn't a number divided by itself, a non-zero number divided by itself, doesn't that equal 1? And using the transitive property that most of you have forgotten about, I mentioned a long time ago, using the transitive property, if A equals B and B equals C and C equals D, can't I therefore say that 1 is equal to x to the 0 power, right? This is assuming x is not 0. It's assuming x is not 0. All right, let's try some stranger looking ones. Look at number 1 here. Now, we simplified fractions like this, but we didn't have negative exponents. I'm going to draw attention to these negative exponents, because with these negative exponents, I need to use the reciprocal. Okay, so let's see here. I'm not going to do anything yet. I'm just going to use the reciprocal on my terms with negative exponents, which just means if they're in the numerator, they'll move to the denominator. If they're in the denominator, they will move to the numerator. So here's what my new problem is going to look like. I'm going to have a 7, and I have an x cubed, right? But this x cubed downstairs has moved upstairs. He's moved to the numerator. Why? Because he had a negative exponent, and I needed to use the reciprocal. The y to the negative second won't be there because I used the reciprocal. And then I have a z to the 6th. Okay. Now in the denominator, I have a 21. The x to the negative third is gone. He went to the numerator. The y to the negative second is coming down as a y to the second. There's a y to the 5th and a z to the 4th. And if I want, I can start canceling, or I can start simplifying. I think I'm going to go ahead and say that, let me change colors there. 7 is going to go into 7 once. It's going to go into 21 3 times. So I'm going to have a 1. I'm going to have a 3. No x's are going to cancel with each other, so I'm just going to multiply x cubed times x cubed, x to the 6th. All right. Y squared times y to the 5th will be a y to the 7th, and none of the y's will cancel. Now a z to the 6th divided by z to the 4th is going to be a z to the 2nd. Now, by the way, this 1 out front becomes unnecessary, and to keep my answer as simple as possible, I'm going to go with this. There we go. It looks kind of strange, but it's actually kind of cool. Okay? So, let's try this again. All right, do this along with me. Let's see, let's go through and identify the negative exponents, because that's where we're going to use the reciprocal. Okay, I see all those negative exponents. Remember, if they're in the numerator with a negative exponent, they're going to move to the denominator. If they're in the denominator with a negative exponent, they're going to move to the numerator. If they have a positive exponent, they're just going to stay put. So, I've got an 8 in my numerator. This fellow moved downstairs. He moved, I guess I can have 4. So I'm going to have an x to the 8th, and below that I'm going to have an x to the 7th. There will be no y's in my numerator. I'm going to have a y to the 9th times a y to the 3rd in the denominator, and there will be no z's in my denominator. They'll both be in the numerator. And remember that when you use the reciprocal, the exponent changes signs. So now I can say, well, that's going to become a 2, and that's going to become a 1. So I'm going to have a 2, and I'll put that 1 there. X to the 8th divided by x to the 7th. Well, that's going to be x to the 1st, isn't it? And it'll be in the numerator. How do I know it'll be in the numerator? Because there are more x's in the numerator than there are in the denominator, right? If I wrote them all out, I think it's only 7, there's 8. Okay, and then I canceled them all. The ones that don't cancel will be left in the numerator, or the one that doesn't cancel, I should say, will be left in the numerator. There he is. Okay, so the x's are taken care of. The y's won't cancel with anything, so I'll have a y to the 12th. The z's won't cancel anything, so I'll just multiply and get a z to the 10th. And that 1 is unnecessary. So, there you go. There's your simplified fraction. Now, number 3 looks a little bit stranger. Don't let it scare you. A negative exponent means to use the reciprocal. So you see this negative 2 out here? I'm going to take care of him first. I'm going to use the reciprocal of the entire fraction on the inside. So my denominator will become my numerator. Oops, that's supposed to be an 11. Sorry about that. And my entire numerator will become my denominator. Now, the whole thing is still raised to the second power, right? Now, I'm not going to worry about squaring. I'm going to simplify everything I can on the inside first. So I'm going to go hunting for more negative exponents. There's a term with a negative exponent. There's a term with a negative exponent. And there's a term with a negative exponent. And remember, a negative exponent means to use the reciprocal. So the x to the negative fourth will come down. The z to the negative 11th will come down, and the z to the negative second will go up. All right, so I'm going to have 25 in my numerator. There will be no x's in my numerator. I'm going to have a y to the 12th and a z to the second. My denominator will have a 15, x to the 5th, an x to the 4th, remember he came down, a y to the 7th, and a z to the 11th, and then the whole thing is still squared. So now I'm ready to do some simplifying. So I know that 5 is going to go in there 5 times. It's going to go into the 15 3 times. Okay, so let's see what I'm going to get here. So I know I'm going to have a 5 and a 3. Now, I've got a y squared over, a y to the 12th over a y to the 7th. Wouldn't that be y to the 5th? Right? I've got x to the 5th times x to the 4th. That'll be x to the 9th. And then z squared over z to the 11th. That'll be z to the 9th, but won't it be in the denominator? Right? Because like if I drew it all out, there'd be z times z. And then down here, there'd be z, 3, 4, 5, 6, 7, 8, 9, 10, 11. Right? And then those would cancel, and I'd be left with 9 z's being multiplied, but they're in the denominator. And so now we're ready to evaluate this. We're going to square 5 and get 25. We're going to square y to the 5th, so that's y to the 5th times y to the 5th, which is y to the 10th. And then we're going to square 3 and get 9. Square x to the 9th and get x to the 18th, and z to the 18th, and there you go. Crazy business. All right. So here's your video quiz. You need to tell me what 9 to the negative second is as a fraction. Tell me what this number, 1,765,210 to the 0 power equals. And 0 to the 0 power. Be careful on this one. Be careful. And we're going to get lots of practice on Wednesday with these strange-looking fractions. All right, that's it for your video. Mr. Lawrence signing off. Have a good night, everybody.